Thank you. Hello, everybody, and welcome. And my name is Payne. I'm co-chair of Information Quality Cluster, along with Rama and David. Today, it's my pleasure to introduce our invited speaker for the March Telecon, Nicolau Manubens. Nicolau is a computer scientist working in the Earth Science Department of Barcelona Supercomputing Center in Spain. He's involved in one of the European projects in his presentation. He will introduce the quality control strategies that are developing for the provision of a seasonal forecast in Copernicus. I met Nicolau at the AGU 2017 conference for meeting last December. When he came to our IQCE lightning session, he was looking for a way to share the best practice they have developed and also give feedback from the earth science community in the U.S. And it is, I think it will be make good sense for him to give a presentation as a start. And let's welcome Nicolau.
Okay, thank you very much, and thank you very much for giving me the chance to present here. As Peng said, I am going to talk here about the quality control and provenance approaches in a European funded project from a producer perspective. I am a computer scientist and I am not the main author of this work. I will rather present on behalf of the whole team. I will start by introducing the Copernicus program. So, Copernicus is the European flagship program for the establishment of a European capacity for Earth observation. On top of in situ and satellite observations, a range of services are being developed as part of this program to monitor and provide information about the atmosphere, seas, land use, and other themes. One of these services is the Copernicus Climate Change Service. For short, I will be using C3S. The C3S will provide information about the climate of the past, present, and future. And this information will be provided at global and regional scales and will be openly accessible through a web portal and mobile applications. It is not fully functional yet, but if you want, you can access it through the URL on the overhead and take a look. I have attached here a screenshot of the portal, of a section of the portal that is showing the records for monthly averages, in this case, of air temperature at surface level. The C3S will target a wide range of users, including researchers and private stakeholders. Two examples of applications of this service could be policy making in the insurance sector and decision-making in the energy sector. These examples are important because they imply that the publication of erroneous products or having a user choose an unsuitable product could lead to third-party losses of huge amounts of money. But we will be back to those responsibilities in a minute. Now, let me introduce the seasonal forecasting activities in C3S. Although the C3S will cover other aspects of the climate change, in this talk, I will focus mainly on the developments devoted to seasonal forecasts. So, the C3S has contracted a number of institutions who dispose of state-of-the-art seasonal forecast systems, commonly named models, and these institutions run the models each month to generate ensemble forecasts. These institutions are represented on the diagram on the overhead by the Earth globes. So once the forecasts are produced, they go usually through a preliminary processing stage and are then ingested by the C3S service. Afterwards, according to users' demands, the forecast may go through additional procedures. In the diagram I have put on the overhead, the steps followed to generate a selected example product are represented. As you can see, the seasonal forecast data in this case goes through different types of procedures. So When generating one of these products, the data can potentially go through many types of procedures before reaching the final user. This is a very complete example, but even when the user only wants the seasonal forecast themselves, usually the forecast data needs to be processed or plotted as a visual product at least. Here you can see an example of a forecast product without quality control information. This product is showing average wind speed forecasts for the upcoming season. Well, this was issued in November 2017 and was the forecast for the average wind speed for the upcoming season, December, January, February. The fact that it doesn't include quality control information is important because it means that this could actually be a bad quality forecast. For example, the model that issued this forecast could be especially bad in forecasting this specific season, for example. Now, 1 second. As I said before, a wrong product could have bad consequences. So the C3S has to take responsibility and follow a robust quality assurance strategy. And in this direction, the Barcelona Supercomputing Center is leading the development of the quality assurance strategy for the provision of seasonal forecasts and related products. The partners involved in the consortium are Predictia, a Spanish private company, Meteo Suisse, and other European and UK partners. Now, when we started this contract, we were not aware of the IQC activities or recommendations, and we rather built upon experience in the consortium and upon some identified principles and the standards for some of the components. I will be mentioning some standards and conventions during the presentation. One of the most essential frameworks the consortium has taken into account is the ethical framework for climate services issued by the Climate Services Partnership. According to this, first, the providers should consider the consequences of their actions for those using or being affected by the use of the products. And second, the products should be open to scrutiny and comparison. So the resulting strategy we have developed is comprehensive, includes activities ranging from assessment of user needs to development of a software prototype. Sorry. All of these activities build upon 3 main pillars that are derived from the ethical framework for climate services I have just mentioned. First, providing user guidance for the user to select the correct product. Second, to provide estimates of the quality of the products or QA measures for the user to know how trustworthy a product is. And finally, provide provenance information, which by one side would contribute to user guidance and by the other side would allow for product inspection and comparison. These 3 ingredients are the only way for C3S to minimize issues and build trust on the service they are offering. I will now go briefly through each of these aspects of the EQC strategy and review the most important aspects. In first place, the scientific assessment. The scientific assessment includes the definition of the forecast quality measures needed to quantify the different aspects of the forecast quality for the different types of forecast available. Once these measures have been defined or identified, high-level rhetoric questions have been formulated for the user to understand the meaning or value of these quality measures identified. For example, a question associated to one of the measures could be, how good are the forecasts? Another rhetoric question could be, how reliable are the forecasts? Or how difficult to forecast is the situation? Other work done here in the scientific assessment is the identification of sources of uncertainty in seasonal forecasting as well as methods to quantify such uncertainty. Finally, we have also collected and suggested a set of graphical products which can represent the EQC information we have detected as relevant. Here you can see an example, again, of a seasonal forecast product, but this time with quality control information included. This time, instead of displaying the forecast itself, we are displaying the deciles according to some past observations. And there is a gray mask here superimposed. This mask represents where the RPSS, the ranked probability skill score, is below 0, which means that the forecasting system that issued this forecast is no better than a baseline forecasting system used for comparison. So here we are darkening the regions of the forecast for which we know that the model was not very skillful. In this case, we are assessing the skill aspect of the forecast quality. Now, moving to the identification of data sources and conventions. This activity has included a few assessment tasks, such as identifying relevant climate variables and aspects of dataset quality that a user should be informed about, but I won't go into much detail here. By the other side, the C3S has defined conventions for the data to be stored, which we have relied on. Here I am summarizing such conventions. In short, the convention establishes what should be the content of the data files, which format should be used, how to structure the data, and which metadata items to store. It results from combining and extending other existing conventions, such as the CF conventions, the work done in the SPECS project, the CIMIP project, and the ACDD convention for the attributes. Well, in short, the resulting convention says that files should be stored in etcdf as a standard file format, and provides indications on how to name and distribute files, which attributes must be defined, and a lot of other items that should be documented for each of the climate variables. Now, moving to the technical assessment activities. Sorry. As I said before, it is important to define a provenance mechanism for the seasonal forecasts to be transparently documented, reproducible, and comparable. So, for this, we have developed this MetaClip model. Just before starting, so it is only possible to think of a metadata propagation and provenance tracking mechanism once you have some data conventions well defined. Now, having the conventions that C3S defined, we have developed this framework called MetaClip that allows for encoding and propagating the metadata involved in climate forecasting. There's a link here where you can check further information. I will review the main highlights now. This metadata model allows to encode the most essential metadata in the form of a directed graph. So these blue balls on the overhead are a graph explaining the involved data sources and containing the most essential metadata. Once this basic set of metadata is encoded, the resulting graph can easily be extended with information on the steps that one may apply to the data involved. Here on the overhead, I have colored the nodes representing processes or steps with green balls. Once all the processing steps are encoded, the graph can easily be serialized as an XML string, which can then be attached to netcdf files or image files. After, the produced data can be the produced file with the metadata can be ingested by a provenance visualization engine, which will interpret and graphically display the provenance and the metadata graph. And here in this overhead, I have attached a video showing a demonstration of this web portal, which allows to drag and drop a graphical product and automatically displays the provenance graph. In this graph, each of the nodes is colored with a different color according to the kind of step it represents. In reddish, we can see the data sources. In purple, we can see the transformation steps. In yellow, the EQC, the QC verification steps, and in green, the outcome. The user can click on the nodes and check details about each of the steps, the parameters used for the particular step, and the software package used for each of the steps, and so on. And has some levels of detail by clicking on the different buttons on top. So we have lots of information here, but the thing is that finally the user can see that this product corresponds to a plot of the AUC verification score for a seasonal for a system 4 seasonal forecast. So the video keeps going a bit more. Well, now MetaClip is based on RDF, which is a W3C standard widely used for the web semantics. And RDF allows to describe relationships between entities or concepts. A set of relationships is called vocabulary. What we have done in this project is taking some existing vocabularies, such as the very well-known prov vocabulary for representing provenance concepts, and other vocabularies such as the sec and the geo, and have extended it with the required concepts for the seasonal forecasting activities. MetaClip is an abstract framework, which means that can be implemented in any programming language for other applications. And so, sorry, as a summary, the main advantages of using MetaClip are that it allows to generate clean and meaningful provenance traces, that it helps in generating description digests of products, for example, figure titles, which is a big challenge, and that it provides a governance solution for provenance standards, since it uses already established vocabularies by the community. Now, also as part of the technical assessment, we are doing some can you hear me well?
Yes.
Hello? Okay. I get some messages saying something about the connection, but I will go on, okay?
Please.
Okay. Then this performance assessment of the EQC, we have carried out a performance assessment of the EQC processes and about the measure calculation on high performance computers in order to assess whether it is possible or not to generate and provide this EQC information in few seconds. We have not finished it yet, but it may be that it is actually not possible to compute all of this in real time when the user requests for them. So then other strategies should be designed, for example, pre-calculating products or cacheing previously calculated products and others. Now, let's move on. I will go quickly through the software prototype. Yeah, I just wanted to mention that some open source software is being developed to generate EQC products with provenance in the form of R packages. And yeah, we are taking also into account the computational performance requirements. Then Regarding the assessment of user needs, all of the activities in the quality control strategy that we are developing are user-driven. We have conducted surveys and interviews in order to identify users' requirements with respect to each of the components of the EQC strategy. And yeah, these surveys and interviews have included themes such as which climate variables and indices they use for their work usually, what kind of processing methods or quality measures they use or lack, or what is the relevance of the different kinds of uncertainty, or what is the relevance of metadata and provenance for their work. And well, I have attached here an excerpt of the results obtained in the first round during the past year, where we asked the users about their interest on the different aspects of the forecast quality. The results are on the first row of charts, and by one side, we see that they are mostly interested on the skill aspect of the quality. You can see a high blue bar in the middle, which corresponds to the skill aspect of the forecast quality. But they are less interested in other aspects, which we had also identified as relevant. By the other side, we see that they don't know about some of the components, which confirms that some user guidance is required and fundamental. On the second row, we can see the results of the consultation about the uncertainty sources. All users were very interested in all of the identified sources, but the methods in the literature at the moment are not quite mature yet. Now, a second survey is taking place the coming month. So please, I would like to ask if any of you would like to participate. You can send me an email to the address I have put on this slide. And so this survey should take 20 minutes approximately. So please, if you would be interested, please send an email. Now, I wanted to finish the presentation with some slides in which I try to identify the points in common between the work I presented and the ESIP IQC activities. I have tackled this with three very simple approaches. In first place, I've taken a part of the abstract of the lightning poster presented by the IQC at the AGU fall meeting last December. According to this piece of the abstract, it says, what was discovered to be most lacking is the transparency of data lineage. This is provenance and maturity, uniform methods for uncertainty characterization, and uniform quality assurance data and metadata. While solutions to these types of issues exist, most data producers have little time to investigate and collaborate to arrive at and conform to a consensus approach. We have worked on all of the aspects mentioned in the abstract. So this is already a first indicator of the commonality between the two activities. The second approach has been to take the summary of technical topics on the IQC wiki page and mark those on which we have worked with green arrows. Well, you can see that most of them have a green arrow next. So yeah, I could go through them, but I think I don't have much time. The third approach has been to look at the maturity framework suggested by the IQC and the 4 dimensions of the information quality. I would place the work we have done mainly on the 2 last quality stages, particularly on the stewardship stage. The stewardship maturity framework by Pang in 2015 proposes 9 aspects to evaluate. We have worked on aspects related to a number of these without following a specific order. So I think the maturity framework would provide some structure to our work and also would help identifying missing aspects in our work. Now, here I have put the summary with the main things I have explained. But the most important conclusions, I will skip these conclusions because are a repetition of what I have already explained. The most important conclusions for me are these here. Sorry. So it seems that the work done is tightly related to the ESIP IQC activities. The IQC recommendations have not been identified soon enough, but should become a reference point for upcoming iterations of the C3S and Copernicus EQC strategy. And that the IQC seems an appropriate place for discussing QC and provenance topics. We have actually been looking for a place to discuss with other projects and entities about these topics. And well, we eventually found it. We would like to stay close to the IQC. And well, that's it. I would just like to add that the presented contract is ending soon, but new instruments are being prepared for to do further work. And if everything goes well, we will keep interacting for the coming years, if you agree. But anyway, when the current contract ends by September this year, we will be definitely happy to share results and publications with you. And well, that's it. Thank you very much for your attention. And if you have questions or suggestions, please go ahead.
Thank you very much for that excellent presentation. And you can go ahead, unmute your phone and ask Nicolau directly, or you can type your question at the chat box and I will read it out for you.
Hi, this is Bob Downs. Can you hear me?
Hello, yes.
Yeah, I have a question, and I have to apologize. I came late, so I might have missed it. But I'm just wondering, when you're talking about the user perspective on the needs that we're trying to identify, whether you're finding a way to look at future user needs, that is, in addition to the current users. Those who might be using them in the future, say, down the line, 10, 15, 20 years from now?
Oh, well, I think we haven't looked so much into the future. All the users we are interviewing and sending our survey to are future users. But yeah, the needs we are trying to identify are needs for the coming 4 or 5 years, I would say. I think that in order to assess needs for the long term, we should keep iterating this user assessment for, say, every 2 years, every 3 years, repeating this procedure. Yeah.
I see. Thank you very much.
Thank you.
Hi, Nicolau. This is David Maroney. I'm also one of the IQC co-chairs. It's a pleasure to meet you, at least virtually. Unfortunately, I was unable to attend the fall AGU meeting, so it's great to have you here. So thank you very much. I wanted to just quickly ask you: are there any elements of the assessments that are currently or planned to be automated, or at the moment are all of these assessments being done fairly manually by humans who are doing the evaluations?
Yeah, sorry. So this is going to be everything automated. This is going to run every month after each of the involved entities delivers the forecast for the upcoming month and season. This will be rerun. And in this direction, we are developing this software prototype, which I quickly went through, which will be made publicly available once it is ready.
Okay, thank you.
Thank you.
Any other questions?
Can you hear me? This is Grace Pang speaking from Boulder.
Yes, I can hear you.
How many people, I looked at your survey results and it was interesting on slide 23. How many people did you said they were future users? How many people did you query, ask, and like what kind of background or sophistication in using this type of data? What kind, how sophisticated were these users? Because I was surprised by how many people thought like things were less interesting than how they weighted what was more interesting and what was less interesting. Or 60 respondents.
So, yeah, there were 60 respondents, and I don't remember exactly the figures, but I can say most of them are specialized users. Like 15% were from National Meteorologic and Hydrologic Services. The other 20% were from research, and the other remaining 40% maybe were specialized from the private sector, and the others were not specialized.
Thank you. Had they used satellite data before? That all of them had used satellite data.
So, sorry, I missed the question.
Were all of them like past satellite users, satellite data users?
Oh, well, I don't know that. I should check more in detail the reports. Sorry, I can tell. I can tell now.
Okay, thank you.
As a follow-up question, this is David again. As a follow-up question to Grace's question on the survey, how do you determine who to target in these surveys and interviews? Do you have an email list to register to become on this list of potentially surveyed users?
We have a list, but it is internal. And so what I'm trying to do now here in this presentation is to ask anyone that could be interested to send me an email. And yeah, we would add the persons interested to the internal list. We cannot make that publicly available, of course. So why? What do you mean? Would you be interested in seeing such list?
I don't think we'd necessarily be interested in seeing the list of names, but just in the event that we might want to refer folks to participate in this activity to provide feedback. So yeah, so the main contact point would be myself or the person who's leading the surveys. I can provide her contact address also. Thank you. Thank you.
Nicolaus' email is also captured in the meeting agenda. If you would like to contact him afterwards or have future other questions, please feel free to participate in the survey or communicate with him. Thank you again, Nicolau, for the excellent presentation.
Let's see, I just want to mention, it would be good to know what kind of people you're looking for to participate in the survey in general. Is it anybody, or is it somebody with some specific backgrounds like you mentioned just now?
Yeah, that's a good point.
I would say anybody is welcome, but we are particularly looking for people who had any kind of experience or who is working on things related to seasonal forecasting.
Okay, yeah, that's good to know. Thank you.
Thank you.
Okay, so I think we've got about 20 minutes for covering the rest of the agenda. So let's